In this and the upcoming tutorial, we will be describing the properties of alkanes, so we will be working on the third objective of this section. The first physical property is polarity. Alkanes are almost non-polar. Remember that the polarity of a given molecule depends on the electronegativity of the atoms in this molecule. The electronegativity of carbon is 2.5, whereas that of hydrogen is 2.1, which means that they are similar. So the difference in the electronegativity is too little for the bonds to be polar. As a result, the only intermolecular forces between alkanes are weak van der Waals forces, and as the molecule gets larger, the van der Waals forces will become stronger. So in the case of alkanes, the only intermolecular forces acting between the molecules are van der Waals forces, which are relatively weak, and as the molecule gets larger, they will become stronger. The second physical property which we will talk about is boiling points. As the intermolecular forces increases, the boiling points of alkanes increase as the chain length increases, which means that shorter chains are gases at room temperature, whereas pentane, for example, which has 5 carbon atoms, is a liquid with a low boiling point, which is 36 degrees Celsius, which is equivalent to 309 Kelvin. At a chain of length of about 18 carbons, the alkanes become solids at room temperature. The solids have a waxy feel. So alkanes may be gases, liquids, or solids, and the physical state will depend on the intermolecular forces which are related to the chain length. Alkanes with branched chains, so those which have sided chains, have lower melting points than straight chain alkanes with the same number of carbon atoms. So if we take, for example, pentane and methylbutane, which are isomers, pentane is a straight chain, whereas methylbutane has one branch, which is methyl, and thus methylbutane will have a lower melting point than pentane. And this is because branched chains cannot pack together as closely as unbranched chains, so the van der Waals forces are not so effective, and thus they can be broken easily.